Hello everyone, I'm Zach Yeldo, and in this video I will be summarizing the second portion of the article Opinion Mining and Sentiment Analysis by Bo Pang and Lillian Lee. In my previous introduction of this paper, I briefly went over the analysis and extraction of opinion information, and we will now be reviewing the aggregation and representation of the sentiment information after it has been gathered. So, just as an introduction, users might desire an at-a-glance presentation of the main points made in sentiment data. And creating these sentiment summaries after extracting and analyzing the data falls on the aggregation and representation portion. So there's definitely a very close connection between the extraction of sentiment-based documents and the summarization of that sentiment-based information, since the information that's being gathered can serve as a summary. And this portion of the sentiment analysis can really be neglected, although it's a crucial part of the analysis, and we will discuss how to use these two in conjunction shortly. So now I'll briefly discuss some points to keep in mind in regards to sentiment summarization. However, progress in sentiment summarization has not yet reached a level where all these problems have come up yet. So these are just things to keep in mind. So first, determining which documents or portions of documents express the same opinion is not always an easy task, but it definitely needs to be addressed in the summarization, since readers of sentiment summaries are interested in the overall sentiment in the texts. This means that the system needs to determine shared sentiments within the document collection, and this issue can still come up even when labels have been predetermined if the items that have been pre-labeled come from different sub-collections. So for example, some documents might have polarity labels, while other documents might contain ratings on a 1 to 5 scale. And even when the ratings are drawn from the same set, calibration issues might occur. And in regards to this, take a look at the picture of a question posted on Rotten Tomatoes. The user asks, on Blade 2 reviews page, you have a negative review from James Bear. I can't pronounce the last name, but you have a negative review from James, 2.5 out of 4 stars, and a positive review from Eric, 2.5 out of 5. Why is James's review labeled rotten and Lorio's review, or Eric review, labeled fresh? And this discrepancy occurs because star systems are not consistent between critics. So for critics like James, 2.5 stars or lower out of 4 stars is always negative. And for other critics, 2.5 stars can either be positive or negative. Even though Eric uses a 5-star system, his grading is very relaxed. So 2 stars could be positive. Also, there's always the possibility of the webmaster or critic putting the wrong rating on a review. So that's something you need to consider. And another consideration in regards to a topic such as reviews of conference submissions is that program committee members must often take into account the fact that certain reviewers always tend to assign low scores to papers, while others might have the opposite tendency where they always give high scores. And this can really tend to skew a sentiment analysis. An additional observation to take note of is the fact that when two reviewers agree on a rating, they might have different reasons for agreeing. And so it's important to indicate these reasons in the sentiment summary. So they might have both given 4 stars to a product, but they have completely different reasons for why they gave 4 stars. And another point is that when a reviewer assigns a neutral rating, it might be because they think that most of the aspects of the items under discussion are decent, but it also might be because he or she sees both strong positives and strong negatives, which kind of balances it out. And so these are two really important things to consider. Or reviewers might even have the same opinions about individual item features, but they weigh these individual factors differently, leading to a different overall sentiment. So we might both like McDonald's chicken nuggets, but I think it's valued at 5 stars and you think it's 4 stars, even though we both like it the same exact amount. Um, and then as a side note, in traditional summarization, redundant information is usually just discarded in a summarization of data. However, in sentiment summarization, we usually want to talk about and track and report the degree of redundancy, since the user of the summary is typically interested in this information, such as like seeing the term frequency or things like that. And the challenge in sentiment summarization is that the pieces of information to be summarized are often conflicting, which can make it a difficult task. So, methods of summarization. One way in which a sentiment summary can be prepared is through text, based on the extraction of sentences or similar text units from the passage. So, for example, one approach was to select a single passage in a document that reflects the opinion of the author and then pull a short snippet from that passage. And this is done for multiple passages, which can then be combined to prepare a full summary. However, this was shown to be very inaccurate, even with high quality extraction methods. Another method that has proven success for longer summaries is to track how the sentiment orientation changes from sentence to sentence in each passage and extract the sentences that are located at the local extrema of each flow, in addition to the first and last sentence of the passage. And using this method, only the most useful sentences should show up. In addition to these two methods, one could also just extract all subjective sentences to create subjectivity extracts, and these extracts could be used as a summary, although they're more useful as an aid to polarity classification rather than a summary. And although textual summaries can prove very useful, there are many occasions where a graph-based summary can prove to be much more useful than text-based outputs. Graphical elements can be used to represent a single bit, number, or grade in a very simple summary, and the graphical summaries are very well suited to summary statistics. Visualization is also much easier to interpret in most situations, and we'll have a chance to review both of these summaries a bit more in the following slides. So, textual summaries. In the example above, you can see different textual summaries that were generated through modification of pre-existing algorithms. So in the first example, we can see a natural language summary in the form of an evaluative argument, which utilizes the classic natural language generation pipeline of content selection, lexical selection, sentence planning, as well as sentence realization. And it assumes the existence of a predefined product feature hierarchy. The system produces textual descriptions of aggregated information, and the system is being compared to an existing sentence extraction system called MEAD on the bottom of the picture. And when comparing these two approaches, you can see the top example is more suited for a general overview, while the bottom provides much more variety and expression in the detail. And these summaries are developed through the extraction of specific sentences based on certain requirements in order to most accurately represent each set of documents. There was actually a website that attempted to determine the mood of current users based on articles they had read and recommended articles that were on the same topic but would affect their mood inversely. And this was only possible through these summarization techniques, so it's a really interesting topic. Here's a graphical summary. So, for example, graph-based summaries are very appropriate when the information that is most important is the set of entities described and the opinions that some of these entities hold about each other. So this figure shows an example of a human-generated summary. So someone actually put this together in the form of a graph depicting various negative opinions expressed during the aftermath of Hurricane Katrina. Note that the inclusion of text snippets on the arrows the inclusion of the text snippets on the arrows support the inference of a negative opinion. And in general, providing some sense of the evidence from which opinions are inferred is really useful to the user in most cases. So I'm not sure if you can read it, but you can see that a bunch of negative opinions are coming towards Bush, and then it tells you why these negatives opinions are coming towards him or whoever else they're going to. And there's actually one arrow from Bush going to Bush, and it's basically him just blaming himself and taking responsibility. So it's very easy to interpret these sort of summaries, and they can be very useful. So here is a graphical and textual summary put together. And as stated previously, summary statistics are often very well suited to graphical representations, and this tree map is on the top, and the text is on the bottom, obviously. But the tree map above shows automatically determined topics discussed in reviews of the Volkswagen Golf, and the size of each topic box indicates the number of mentions on that topic, and the shading of each topic box ranges from red to white to green, and this indicates the average sentiment, ranging from negative to neutral or none to negative. At the bottom, the sentences most indicative of negative sentiment for the topic Volkswagen service are displayed, creating a combination of a graphical and textual summary, and there have also been approaches utilizing natural language summarization in conjunction with these graphical summaries. So you can also see that the shading is a little bit different for each of these boxes, and we'll talk about that in later slide, but this is a really interesting way to represent and summarize the information. You can really understand everything pretty well by looking at this. So bounded and unbounded. The term bounded refers to summary statistics that lie within a predetermined range. For example, the average number of stars, 0 to 5, or maybe the percentage of positive opinions, maybe 0 to 100. For these type of statistics, and also unbounded is without a predetermined range, or continuous. So for bounded statistics, thermometer type images are one method of displaying the information. For example, the tomato meter on Rotten Tomatoes is a bar broken into two differently colored portions, indicating how many positive and negative reviews there were for a movie. And this representation can be extended to N categorization schemes via the use of N colors. One can also use color shading when depicting bounded summary statistics. This is usually appropriate when the display is very limited, and color shading was used in the previous slide that I mentioned earlier. So you can see, like, this is dark green, which means that there were much more, the sentiment was much higher for Drive than it was for Price. So that's a very useful indicator. And you can with this representation, you can quickly determine what was liked and disliked about the product under discussion, although there are so many different products here. So just by looking at this, you can identify the top two topics right away. So thermometer graphics and color shading can be used to represent bounded statistics such as the mean, or in case of N-color thermometers, relative distributions of ratings across different classes. However, bounded statistics by themselves do not provide other important pieces of information such as the actual number of opinions within each class. So another example of that would be that the observation of 50% of reviews of a particular product being negative is more of a big deal if that statistic is based on 10,000 reviews rather than if it's only based on 2. In the two systems that were just described, the average polarity is represented via color, and both represented the quantity of opinions given on a topic via size. This means that the count data for positive and for negative opinions are not explicitly represented separately. And in other systems, this is not the case. Rather, frequencies for different classes are broken out and displayed. For instance, Amazon displays an average rating as the number of stars as a number of stars with the number of reviews next to it. And mousing over those stars brings up a histogram of reviewer ratings annotated with counts for like the 5-star reviews, the 4-star reviews, etc. An example of a method to break it out is shown here. In the figure, although it's a bit small, you can see that the portion of the bar projecting above the centered horizon, so that's the horizon, and these are the bars, and there's separate ones for each product category. So you can see the horizon line represents the number, the bar above the horizon line represents the number of positive opinions about a product feature, and the portion of the bar below the line represents the number of negative opinions. A nice feature of this visualization is that because of the use of a horizon line, two separate frequency data points, the positive and negative counts, can be represented by what is visually one object, namely a solid bar, and one can easily simultaneously compare negatives against negatives and positive against positives. So you can really see and visualize everything right here. And this comparison can be made much more difficult if the bars are all planted on one end at the same location, like a typical histogram, because it makes it very difficult to compare all of the numbers. So how do we identify what opinions are good and bad to use? When creating summaries of reviews or opinionated text, an important type of information that deserves careful consideration is whether or not individual reviews are helpful or useful. For example, a system might want to downweight or even discard unhelpful reviews before creating summaries or computing aggregate statistics. And this is not always a bad thing. Alternatively, the system could just use all reviews but provide helpfulness indicators for individual reviews as a summary of their expected utility. Some websites already gather helpfulness information from human readers. So, for example, I'm going to use Amazon again. They annotate the reviews with comments like 120 out of 140 people found this review helpful, meaning that out of the 140 people who pressed yes or no, you know how many of them thought it was actually helpful. And this can be used as a utility evaluator. And many reviews really just receive very few utility evaluations. And this can be because maybe the reviews were so bad that nobody even bothers to rate them. But this doesn't always imply that the reviews without evaluations are unhelpful. And we really can't assume this of reviews that were just written really recently because they might not have been read by many people. And one attempt to solve this issue was to automatically rank a certain set of reviews on a website according to their helpfulness or utility using a regression formulation of the problem. One important role that automated helpfulness classifiers can play is to provide utility ratings in many cases when human evaluations are lacking. And so those are ways of identifying the quality of individual reviews. And an alternative approach, which is really a great way to identify quality, is to look at the quality of the reviewers. And doing so can actually be thought as a way of classifying all the reviews authored by the same person at one time, which can probably cut down a process significantly if it's done efficiently. And so in conclusion, we discussed the aggregation and representation of sentiment information as after it has been gathered into a summarization, and we reviewed the types of textual and graphical summaries as well as the bounded and unbounded summary statistics that can be used when preparing these summaries. And we also looked at some issues in regards to the quality of our sentiment data and possible resolutions to these issues. Thank you for listening.